and distinguished guests. Good afternoon to one and all. I am Gaurav Bhatnagar welcoming you to the fourth technical session on productivity enhancement and process optimization. We are delighted to have Shri Dinesh Ji Randad, Director Works, Gujarat Sidhee Cement. I request you, sir, to kindly come on the dais and share the session. Thank you, sir. May I now invite Shri Sanjeev Srivastava, Joint President, UltraTech Cement Limited, to kindly join our respected chairman and co-chair this session. Thank you, sir. I would also like to invite Shri Anil Kumar Popri as NCB representative to kindly join the dignitaries on the dais and start the proceedings. Thank you, sir.
Yeah, good afternoon, everyone. The now session will go with the productivity enhancement and process optimization 1. This session is chaired by Shri Dinesh Randad ji, Director Works, Gujarat Sidhee Cement, and co-chairman by Shri Sanjeev Srivastava ji, Joint President, UltraTech Cement Limited. And I request Chairman sir, please start the proceedings.
Good afternoon, everyone. It's my great pleasure to chair this session. I am thankful to NCBM for giving me this opportunity. This really I feel this really very good session, very interactive, interesting, and innovative. As you know, productivity enhancement and process optimization techniques lead to the elimination of non-value added activities in industries by identifying the best and effective manufacturing process to achieve improvement in terms of reduction, increase in quality, and profit. Different techniques are extremely used in industries for recognizing and eliminating the non-value added activities, aiming toward effective utilization of resources and productivity improvements. In the last 20 years, the rapid evolution of products, changing of users' need, and global competition have forced the companies to redesign manufacturing chains and taking into account not only the productivity, but also the quality, economics, and flexibility of operations. This reason motivated and increasing the number of enterprises to research and evolve their production system by automation and optimization, both technically and economic impact on wide sector of production chains. Optimal control can exploit it to optimize the objective, target, function defined in order to reduce production time, cost, and increase in quality. Cement industry has also taken a wide steps in optimization and productivity enhancement by putting a lot of new ideas for production enhancement as well as process optimization. I'm sure this session on productivity enhancement and process optimization will be very useful and interesting for each and everyone. During this session, there are total 8 presentations, and due to as time is short, we are giving 7 minutes to each presenter. So may I request first presenter, the first presentation on impact of rotary kiln burners, design on process performance by Mr. Suresh Tangarasu, 5 Combustion System, India. Please welcome.
Good afternoon to everyone. Myself is Suresh. I am working with the FICE Combustion Private Limited as a general manager. FICE Combustion System Private Limited is a part of FICE Pillar Group, and our presence in India since 1995. So today my topic is impact of rotary kiln burner design on process performance. Before that starting presentation, just I want to have some highlights about the fuse. Basically, means like we always call it as a FICE. It is not a FICE, it's a fuse. It's a Fuse is a, it is a, it's a village name in France. So that is what we pronounce as a Fuse. Fuse has a 19 vertical business. It is actually, it is more than 8,500 employees working across the globe. And we are present in all over all the industry. So here actually Faiz Combustion Private Limited, we are the part of Energy Division. Energy Division has a combustion division, combustion group, and a cryomech, and also sugar. So in this actually combustion, we are covering across the global. So we have 5 regional office across the, these are the places. You can see this Faiz Pilat is located in Paris means France, Marseille. This is the headquarter. And second location is Faiz Pilat, Germany. And third place is actually Faiz Pilat, Spain. And fourth location we have Faiz Pilat, China. And fifth is actually, it is located in Vadodara, Faiz Combustion Private Limited. We are close to 95 employees. We are working together. We have big, factory setup also. So in each year we are manufacturing more than 50 to 60 kiln burners in India here. It's a very interesting things also. Actually, in combustion Faiz actually we specifically for rotary kiln burner we are working more than 100 years. More than 100 years. If you see that actually this revolution which we started somewhere in 1942, 43 somewhere. We started, burner for oil firing system. So this was a need of industry actually that time. If you see that, why I wanted to say this means actually, Faiz actually, this Faiz pillar always work for the industry need. And actually we are developing ourselves and based on the requirement. And second, actually we had somewhere in 1958, we brought with a gas firing system. It's a kiln burner for gas firing. And third, actually, we somewhere in 1972, we got it pillar burner for coal firing system. So that there is a big revolution in 1987, because if you see that in India also we had somewhere in 1985, a lot of cement plants has come up. It's not only in India, globally there is a big revolution. So we brought with the rotor flame, which can fire with all the fuels, multi-fuel. So multi-fuel burner and with the multi-channels. So this was a big revolution which we created at the, Pilat. And somewhere in 2005, we brought with no flame, what the industry needs, specifically for improvement in clinker quality and NOx reduction, this and that. And there was a big revolution again 2020, because this today also discussion, also this seminar, NCB seminar, totally we are focused with the net zero carbon, also higher alternate fuel substitution through our pyro system, how we can be brought. So this 2020, whatever we taken with, it's specifically designed to have a low NOx emission, also to have higher alternate fuel substitution. So which we'll discuss something about also. Before that, we will make it up a case study also, and how will be impact with our burner design, how will impact with your performance. That also we will discuss about this. So these are some highlights that what are the latestly we are taken with new innovation and maybe improvement point of view, how we taken with some of the achievements. This is one kiln burner is operated with 24 tons per hour, which is in one of the Germany plants, and we have more than 700 burners are installed across the global, which has no flame evolution, and we have 166 installation which there with alternate fuel firing system, and where we are operating with nearly about 22 up to 90% substitution through kiln burner. So this we'll see the later. Okay, why you need a burner design? This is actually why you need. You can give a simple. You say megawatt. This is my burner megawatt. So I'm giving a simple burner. This is actually it is not the case of you give some burner. It is each and every burner, each and every system. You need a proper design. Proper design. What is the customer priority? Means what is the operator priority? You have to define the operator priority. Based on that, you have to take a call. See, first is mixing of maximum efficiency. Of course, your secondary air or your primary air, also your fuel, so has to be taken care with proper mixing. And you should always have a short ignition distance. This is objectively, you have a better mixing, also short ignition. Why you require? You should generate the optimum thermal profile. So that we will discuss next slide. And second is burner with large adjustment. So if I'm designing the burner with alternate fuel means if I'm designing burner with the coal means it has to operate with petcoke with alternate fuel, whatever the design condition. Alternate fuel substitution can be, depends upon type of variety of fuel or depends upon type of like moisture content, size of ASF, it can be percentage distribution can be changed, but it has to operate accordingly that, what is it. So you should have a large flexibility. Your burner design has to be taken care accordingly. Third one is making the right size and the momentum. So this is a, kind of art. Actually, if I give 7 Newton per megawatt or maybe 9 Newton per megawatt, what is the purpose which I want to, what is the purpose which I have to, okay. Just
1 minute, please.
2 minutes. And fourth is actually no compromise and the burner mechanical reliability. So this has to be taken care. And no locks, better locks. So this is what actually I was telling about. You should have a better NOx, means you should have a short distance, and also this is how you take care of your mechanism. This is a concept how you can able to reduce your NOx. NOx is actually contribution is coal conveying air is much more than your radial or axial air. So this is the kind of technique how you will take it up. See, this is I was telling about 3 technologies: rotor flame, no flame evolution. This no flame evolution is specifically taken care with higher alternate fuel. So actually, I want to present some case study also. How this is with the no flame evolution. We have many case study. There are 3 case study I have taken with the different customer. One was the no flame means one was the clinker quality. Second was alternate fuel substitution. Third one was low primary air percentage. So if you see this, we taken with some design consideration, and actually it was before after installation you can see that the customer has given benefit of 5 to 8% lesser in electrical consumption, also better clinker elect structure. So there was a good reduction in clinker elect structure. So this is, and the second topic was just 30 seconds at this topic.
Please find out fast.
Okay. If you see this, actually, there was a, the 5 plant means there are 5 kilns installed in single location. So customer was asking about 40% substitution. So we taken with the repeated order with one of the client. So we had a system supplied for the 5 kilns. So the customer able to achieve the 50% substitution. You can see 8,500 kg per hour for the coal what we designed. ASF flow rate was 8,000 kg per hour, but which they can go up to 9,500 kg per hour, which is close to 45-48% substitution. And this is one of the client for asking for low primary air percentage, better NOx reduction. It was in India, and you see this actually 6% what we guaranteed 5.1, and guarantee NOx was the kiln idleness something around 40% reduction was there. So this is actually how was we are working with the customer, and also what priority customer is demanding. So that actually we can taken care, and we can able to have the better burner design. That is what actually I want to make it conclude. And this is no flame evolution, which we in 2020 we taken, which has a very good flexibility. You have to define that what is the necessity. Accordingly, we can taken care with the burner design. So this is actually about the features of this one, this no flame evolution. That's it. We have 2 configuration. That's it.
Thank you, Mr. Suresh.
Thank you.
All participants are requested, all presenters are requested to kindly finish their presentation within 6 minutes. 1 minute can be extended, but maximum 7 minutes, as time period is very short. So we have to cover entire thing. And question answer session will be taken at later stage after all the presentations are over. Now next presentation on use of yellow shell from mines for improved kiln feed vulnerability and improved clinker quality. Very interesting topic. A case study by Mr. K.S. Dangi and his team. Please come on the stage.
Good afternoon, sir.
Good afternoon.
Chairperson, esteemed representative of NCB and all guests invited here. Myself, Kamal Dangi, on behalf of the JK Cement Muddapur, I would like to thank you, NCB, for providing us to showcase the study of yellow soil from mines. JK Cement Muddapur is a flexi company. JK Cement organization established in 1975 under the great leadership of late Yadupati Singhania Sahab. Our group, we are involving in grey cement and white cement manufacturing. Our grey cement capacity is 16 million per ton annum, and white cement is 1.2 MTPA. For our Muddapur plant capacity, for the clinkerization is 2.2, and the cement capacity is 3.5 million ton per annum. We are certified with the various ISO certification, and in India, only one integrated plant is Greenco Platinum rated. This is our major process equipment from crushing to packing plant. Our mines has received 5-star rating from consecutive 2 years from Ministry of Mines. We have state-of-art APAR laboratory and well-equipped concrete laboratory. And for the raw mix control, we have a CBA and robotic control system. That plant does not have any CF silo. That directly raw mill goes to kiln feed. The raw mix uniformity is a challenge, but team efforts convert into opportunity. We always focus on conversion from spark of opportunity to frame of achievement. In the same line, the Muddapur plant has a big challenge for the vulnerability of the raw mix. The vulnerability is moderate to poor, and the vulnerability is inversely proportional to free line. The team exertion done to reason for the excellency in the vulnerability of some limestone pile. It was observed that the limestone pile made with use of around 1 to 3% of the yellow cell exhibited good kiln performance and consistency quality. And detailed laboratory investigation done by the lab to understand the various percentage of the yellow soil for the improvement in kiln performance and quality. The present paper deals influence of the yellow soil on burning of the raw mix at temperature below the attenuated temperature, reduction assessed by reduction in free lime by 1%, C3S formation, clinker quality, and improvement in kiln performance and throughput, vulnerability factor, and improved hydraulic property of the clinker. Additionally, able to use ore burden of the mines, which converts towards the natural resources. This is an area where we have identified the yellow cell in our mines. Our capital mines has different types of yellow cell. The elemental composition of the various yellow cell determine the XRF and wet analysis and fusion temperature. We have collected the sample from 5 locations. In that one location, DMP MRS2 found the material that is a yellow cell which has a high iron content and low free silica. That is, the fusion temperature is very low. In that area, we have collected more samples, and we identify the range of the fusion temperature from 900 to 1200 degrees centigrade. And in that one, very low fusion temperature, 900 degrees centigrade sample we selected for the further analysis. In order to evaluate the raw mix, use of yellow soil on reactivity of raw mix prepared with yellow cell incorporating the fuel as corresponding to the S absorption in the plant, assessing the sinterability and burnability. We have prepared the raw mix for the burnability, and based on the burnability, some interference is drawn. Sintering is indicated by shrinkage and expansion percentage, decarbonation indicated by initial expansion, solid-solid reaction indicated by gradual shrinkage, and liquid formation indicated by steep shrinkage pattern, and slope steepness indicated raw mix reactivity eventually to liquid formation. It is shown in the graph. When the temperature is higher, the raw mix with the yellow cell is a better performance. Thus, an raw mix with the yellow soil is indicative of the improved sinterability and would reflect in improved kiln condition. This is a lime combined ability chart, which is the performance with the yellow cell is better without yellow cell. Some observation is drawn with the lab trial data. There is no appreciable difference in the calcination characteristics of both raw mix. The expansion and shrinkage curve, the expansion percentage up to 1000 degrees is more in raw mix, with yellow cell indicated higher rate of solid-solid reactions. Higher sinker characteristics, higher liquid formation. The lime combinability of the raw mix with yellow cell is comparatively more indicating improved burnability. The extent of C3S and C2S formation at the sintering temperature about 1300 more in yellow cell raw mix. There is a two value we have determined with the lime combinability, burnability value with the raw mix and without with yellow cell and without yellow cell. There is a totally 50% reduction is observed in the yellow cell, 12.92 with the yellow cell and without yellow cell 21.77. The lower BC value of correspond to higher burnability of the raw mix. Based on the laboratory investigation, the plant had decided to use of yellow cell for the plant production. The plant have a CBA for the pile preparation, and each pile capacity is a 50,000 ton, which is catered for the 5 days production. So we have prepared 2 pile with the without yellow cell and with yellow cell. We have observed some difference with this one. The free lime reduction is almost 1%, and C3S we get the 50. This is the plant internal data for the before and after. We have seen the improvement in the C3S and as well as the reduction in the free lime and throughput of the kiln. Observation on the plant scale. The trial with the yellow cell indicative very stable burning condition and improvement in 20-day strength greater than 50 MPa, and it is a help to improve the clinker factor. Since our clinker is high MGO, with the reduction of the free lime, the LC and SC sound test is also good for this one. Earlier we are not using the yellow cell, so our kiln performance not was stable. There is a lot of variable. Without this, with the yellow cell, we have a stable kiln operation and we reduce the iron content also in the clinker. Subsequently, after this one, the mines team create a buffer stock of yellow cell to continue in the plant. The conclusion is that the yellow cell had lower fusion temperature and conventional clinker liquid formation temperature, enhancing the C3S formation, improve the kiln feed burnability and pyroprocessing of the performance. Resultant in improved clinker quality also result in achieving lower clinker factor in blended cement products. That conclusion of this one, the plant which have like this material which has a lower fusion temperature may be used in controlled way to improve the kiln throughput and clinker quality. Thank you.
Yeah, thank you, Mr. Rangi. Now, next presentation on problem solving quality improvement tools by Mr. A.K. Agate and Mr. Mani, cement sector expert. Please come on the stage.
distinguished dignitaries on the dais, and all the assembled delegates from India as well as from the overseas. मेरा आप सबको नमस्कार. On behalf of ACC Kaimur Engineering Institute, that is the KEI Diamond Group, which was formed recently, and this is the institute, probably many of you must be aware. This was the brainchild of Telco chairman, Mr. Sumant Pulgaonkar. When he was electrical engineer, that time he established this institute, and we are some of the products of this institute. My co-author, Mani Pangan, he could not come for this presentation, but he has conveyed his message. As it can be seen from these images, that we experience varieties of problems during the cement plant operations, maintenance, sales, and logistics. Human resource, finance department, service departments, everywhere we experience some kind of problems. We have given the caption for this paper as a problem-solving tools or quality improvement tools. And these are basically based on the Juran's trilogy. This Juran trilogy this is the model first he has given, which is being practiced intentionally or unintentionally by many of us, where we are required to identify the project, establish the project, diagnose the cause, and remedy the cause, and hold the gains, and replicate elsewhere. This is the trilogy which talks about the performance under y-axis, and the x-axis is the time where we normally observe fluctuations in every systems. Now these fluctuations are nothing but the process variations which we experience. And when there is some sporadic spikes, that is an opportunity to look for some improvement and take some corrective actions. And once we have done that, then gradually you enter into the next quality control zone or a better quality control zone. Now, how to go about in problem solving? So data collection, tools, and structure, these are the three things which are very much required for problem solving exercise. And besides that, you require a good team. When we talk about data collection, data can be collected in this particular fashion, and that can be properly structured and that can be analyzed. More details have been explained in my paper. Now this is one of the tools, flow diagram, which helps you in understanding the process. Graphs and charts, these are very common things which every one of us know, but it has to have some consistency, simplicity, truth, and information should be very clear. Then stratification is another tool where, see, this example has been explained in the paper about the marketing and salespeople. Then these are the brainstorming, cause and effect diagram, Ishikawa diagram, Pareto analysis. All of us are aware of it. So these also are very much helpful. Details you can please read in the paper. Then scatter diagram, histogram, and box plot. These tools, I have seen many of the presenters have already used it, and these are very useful tools. So just to conclude, keeping in view the time constraint, I'll just read out the conclusion. There are a host of statistical tools with formula which can be used during the problem-solving journey. The basic difference between these 10 analytical tools and statistical tools is that when we use these tools, the outcome of problem-solving process is expressed in some kind of pictorial form or pattern-like statistical form, not like a statistical formula. Very little mathematics is required to be applied. Secondly, the advantage of application of quality improvement tools is that it helps in effective communication to the top and bottom level of management because of the pictorial presentations. These presentations are normally understood easily by everyone and the communication becomes more effective. Information technology is advancing with leaps and bounds where artificial intelligence and machine learnings have taken birth. Businesses are generating large amount of data. Buzzword is big data analytics. That is the process of examining big data to uncover hidden patterns, unknown correlations, and other useful information that can be used to make better decisions in businesses. Softwares have also developed for these tools. Lastly, why not to learn and implement these tools to derive the ultimate benefits in various areas like quality, cost, productivity, thermal and electrical efficiency in manufacturing and service sectors in a cement industry. Thank you very much for patient listening. Last but not the least, let me thank NCCBM authorities for giving me an opportunity to share my learning on problem-solving quality improvement tools. Delegates may refer to my LinkedIn profile also. They can contact me through email and WhatsApp number for imparting customized technical sessions to their staff. Thank you, sir.
Thank you very much, Mr. Gate. Now, next presentation on case study for migration of yellow core appearance in clinker by Mr. Narendra Divakar and Mr. Satyendra Kumar. Both are from Prism Johnson Limited. Please come on the stage.
Very good afternoon, respected Chairman Sir, Co-Chairman Sir, NCB representative, and all the respective delegates, my seniors and colleagues. This is a case study conducted for the elimination of yellow core appearance in clinker at Prince Johnson Limited. Myself, Satyendra Kumar, on behalf of Prince Johnson Limited, I am representing this paper. Yeah. This is about organization. This is our plant, 5.6 million ton capacity, and we are producing OPC and PPC. These are the contents of this presentation. Business objective of this study, what is the background behind this study, causes of yellow core in clinker, and what are the actions taken to mitigate this yellow core, results and discussion and conclusions. Yeah, this is the background at Prince Johnson Limited. Especially in Unit 2, we were facing problems of yellow core appearance in clinker, and sometimes this phenomena remains for many days. And this problem was not causing only quality issues, but also it was related to the customer satisfaction because it was imparting color variations in the cement. And these issues were related to the customer satisfaction. Therefore, we have identified and various causes which were responsible for the color variation in cement. Some major causes are reducing conditions and poor flame characteristics due to long flame, and unstable kiln and process conditions, variations in kiln feed quantity and quality, presence of volatiles and low melting compounds, alkalis and chlorides, etc., and percentage liquid content and uses of AFR. These are the pics of clinker nodules. When we break the clinker nodule, it shows yellow core appearance in the clinker, and in the microscopic evaluation also, we have seen that there is some allied decomposition observed, which is mainly due to the reducing conditions inside the kiln. And after that, to identify the probable causes for this issue, we have conducted a brainstorming session with cross-functional team, and after that some causes were validated and shortlisted for the action plan. This is the fishbone diagram, which is related to man, method, machine and material, and heavy coating at kiln inlet and improper cleaning schedule is related to man, so we have to take action on this, that timely we have to clean the kiln inlet and other things. This was related to method, CO at kiln inlet. and due to TAD damper worn out. CO at kiln inlet due to snowman in cooler, which is causing deficiency of secondary air, and this is machine related traditional burner which causes long flame, and it also causes reducing condition and yellow core inside the kiln. High deviation in kiln feed quantity because of SFF, and this was also taken into consideration. And related to material, high SO3 content in limestone and variation in kiln feed quality causing entry of less calcined material to burning zone. This is just a simple study to identify how this yellow core formation occurs inside the kiln. This is due to easy melting of the material due to presence of alkalis and sulfides, etc. Balls formed in the transition zone at temperature around 1100 to 1200 degrees Celsius, and due to agglomeration effect, these balls grows, and when the clinker is formed at a flat temperature profile in the kiln, due to long flame also causes same phenomena. Uses of AFR like plastic waste, sludge, tire, etc. also causes ball formation due to addition of more low melting compounds. These are some actions taken to eliminate this issue. We have installed the air blaster control cooler so that snowman formation inside the cooler can be avoided, and secondary air will be improved for the better combustion inside the kiln. Installation of Fister in place of SFF, because SFF was causing very huge variations in the kiln feed quantity, and to avoid this, we have installed Fister, and replacement of traditional burner with new burner, high efficiency burner. For short and intense flame, to improve the burning condition in the sintering zone, to improve microscopic structure of alight and blight phases. And adjustment in burner position. Burner position was adjusted and shifted by 75 mm towards material inside kiln to increase secondary air exposure of the material, and Megotox test was implemented to check the reducing conditions, because this test is very easy to conduct and find the reducing conditions inside the kiln, if any. And erection of hump in TAD to improve oxygen level at kiln inlet to avoid CO formation. These are the photographs of the actions taken. This is the results and discussion. After implementation of the proposed actions, clinker appearance improved from yellow to black. These are the following improvements. Clinker granulometry also improved, and plus 50 mm nodule size was reduced from 3% to 1.6% on average basis, and clinker strength also improved by 2 MPa, and clinker productivity also increased by approximately 500 TPD by implementing all these actions. Here you can see that clinker strength, which was previously ranging from 24 to 26 MPa, was then ranging from 27 to 29 MPa. This is the major gain. And due to the replacement of the burner, high efficiency burner we have replaced, and the primary air requirement and the flame momentum was improved. Almost 1/3 of the primary air requirement was reduced. These are the conclusions. Yellow core was mitigated, and clinker quality also improved. Improved clinkerization inside the kiln resulted into better productivity, elimination of reducing atmosphere inside the kiln, and less primary air requirement with high efficiency and new generation burner, and improved customer satisfaction, which was our ultimate motto, due to elimination of color variations in the cement. You can see that before the reducing conditions were observed in the Megotox test in red color, and after the implementation of all these actions, the reducing conditions was eliminated, and the clinker appearance also improved. And this is the picture of clinker before and after. Here you can see that before, yellow core is present in clinker in abundance, and after that, yellow core is completely eliminated. Yeah, thank you.
Thank you, Mr. Satyendra Kumar. Now, next presentation on flash activation of clay, high product quality, and energy efficient process by Mr. Dinesh Excel Smith. Please come on the stage.
Good afternoon all. Thank you for joining this session. So now we will be speaking on the most efficient way for activating a clay. So the agenda for this discussion will be why we are talking about clay calcination at this point, and what are the clay sourcing, and then FL Smith clay activation technology, and a brief comparison between kiln and calciner technologies. So when it comes to the drivers, as we all know, emissions, CO2 is the primary drivers. So when we talk about CO2, there is a point we should understand. Any optimization is leading to reduction of a CO2. But when it comes to the magnitude of it, the prioritization, reduction of clinker percentage plays a vital role. So that is where we talk about SCM, supplementary cementitious material, because we all know that 60% of the CO2 comes from decomposition of calcium carbonate, 30% comes from the fuel consumption, and 10% contributes to the electrical energy. When you talk about clay calcination, the clay, activated clay, actually addresses all of this, because by reducing the clinker percentage, by also it is produced at a low energy consumption and also low power consumption. So it is not only about reduction in the CO2. Actually, it also helps in terms of enhancing the productivity. So the combination, you can see, so any combination which can reduce the emission but also improve the productivity is the best combination ever. So clay calcination or the cement, limestone calcined clay cement, LC3 cement, solves this purpose. And other drivers are, this depends on the market to market, where we have a lower supply of fly ash and slag. It depends on the regions and also the cost economics. And then there are some places where we don't have limestone. When you talk about the roadblocks, there are of course the same point again. So when there is an abundance of availability in terms of slag and fly ash, still there is a challenge in terms of cost economics. And then it comes on the end user need. For example, the confidence in the end user about the norms. Even now we have the BAS norms ready, but it is not established, and also doubts in terms of quality of strength or in terms of color. So the acceptance in the market is one of the roadblocks we see here. So starting with the clay sourcing, so we all know not all the clays are same. So we can talk about substituting a clinker up to a 40%, but it is not that all clay can do it. So we need to, any clay has to be assessed, and it doesn't stop with XRF. We need to do the mineralogy testing of the clay. We need to understand the mineralogy of the clay, the binding between the siliceous and aluminate clay. So we are not here looking for a purest form of a clay. What we are looking for is just a 40% kalinitic clay, which can really solve the purpose of giving an equivalent strength equivalent to an OPC, which we'll see later in our slides. So once we do this testing in terms of mineralogy, then we need to understand the thermal reactivity. So it will be treated thermally so that we understand the optimization temperature. And then we will talk about the color control, because that is very, very essential. As we all know, color doesn't contribute to the strength, but it is a mindset to the end user that definitely color is an important factor. And finally, we'll see the reactivity of the clay. So this is a process before getting into any conclusion that any clay can do any kind of substitution. So each and every clay is very important. So here is a critical example of why the mineralogy plays a role. So when clay is having a proper crystalline structure at an availability, it has to be treated thermally. And when it treated thermally at a certain temperature, it is a smaller window. So the playing at that window or maintaining that temperature window is very essential. So in that case, we are trying to disorder the clay, trying to make it amorphous, and then we get the maximum activation. Once the clay, the thermal temperature crosses that limit and goes beyond that, then again it recrystallizes, and then the reactivity of the clay or the end substitution actually affects. So that is what this graph represents. So this is one of the pilot installations what we have in FL Smith, where we can produce even 100 kg per hour of clay with a proper gray color, which we get it in the cement. So here we have a pilot scale of flash activation of clay, and then finally grounded along with the standard clinker to understand what is the strength of the clay. So this is one of a research study which is indicating with a binary system, that is only with the 70% clinker and along with the SCM, that is clay, and then a ternary system which is along with the limestone. So when you are talking about calcined clay, we are also talking about addition of limestone. So if you see the strength here, I don't have a pointer, but the first bar in the chart indicates the OPC, and the second one is with the clay, and the third one is the clay and limestone. So when you talk about activated clay along with limestone, there is a little sluggishness in the early strength, but when you talk about 4 days, 7 day or 28 days strength, it is almost same as OPC, and it is better performing compared to PPC or any other blended cement. So we have a technology in terms of flash activation, which is already there in our mining industry. So it is a proven technology. We are adapting the same technology into our activation of clay. So this is a simple circuit of clay activation where you can see the clay is being, it has to be, see the clay comes under high moisture and also a different size, say 150, 200 mm. It has to be size reduced and then taken into the preheater system to preheat, and then the activation happens in the calciner. So when we do a calciner system, it solves multiple purpose. So we can add as much as alternate fuels as well compared to a burner in the kiln process. So that is one of the biggest advantage. And also we adapt this cooling technology with the static cyclones. So we don't have any kind of moving equipment. It is a static structure with a very, very less footprint. So we have preheating cyclones, activation in the calciner, and then a cooling cyclone. So if you see just an example of having a 20% moisture clay consumes about 425 kilocalories, close to 425, 430 kilocalories, and this overall circuit takes about 12 to 14 kilowatt hour per ton. We need to understand here we are also eliminating a part of drying. So for example, if I'm talking about substituting of 30% clay, then we have to grind this 30% limestone, for example, compared to clay in a raw grinding, which also requires higher capex, a bigger mill, and a bigger investment. So this is just a comparison between the heat consumption with respect to the moisture. As from 15% to 30%, you can see the fuel consumption ranges. So when it comes to color complaints, it has been a major concern, and of course we have a solution which is a patent pending solution where the concept is to have a reduced atmosphere so that the hematite, which is converted at about 600 degrees into a magnetite form, retains in the magnetite form. So the gray color doesn't come back to the reddish brown color. So in that way, we have to take a partial fuel into the reducer box, and we are even recuperating that heat back to the calciner, and also we are recuperating the heat from the cooling cyclones as well. So when I say the most efficient way, we are doing as much of recuperation possible so that we are recuperating all the heat back into the system. So this is just a few comparison in terms of the OPEX, where we can see how much of CO2 is reduced. I made it very practical so that I added PPC also in this. Globally, it can be only OPC. You can see it about 25% of CO2 is reduced in terms of compared to a PPC, but also when it comes to the production enhancement, it can be 150% of increase in capacity and CO2 reduction of 20% here. So when it comes to kiln, just a few seconds I will take for this. It is, of course, we don't have a very big temperature control, and also we form the surface area matters a lot. So you get a coarser material which affects in the activation part, and inconsistent calcination is also happening in a kiln technology. So this is a high quality product and low capex and low OPEX, as I explained. So this is more environmental friendly solution what we have here. So these are the two contracts which under execution, which will be under producing by first quarter of next year, one in France and one in Ghana. Thank you very much for listening.
Thank you, Mr. Dinesh. Now, next presentation on reducing the manufacturing cost of cement and increasing the profitability of cement by using pond ash instead of fly ash in cement mill. The presenter is Mr. Cantt, Process Expert Services, India. Please come on the stage.
Happy afternoon, respected chairman, co-chairman, and NCB members, and my dear friends. I am Cantt with 47 years of total experience and worked on most efficient plant in India, such as Shri Cement, Vasodhatta Cement, and Dalmia Cement. Now I am freelancer consultant for reducing the manufacturing cost, improve the productivity. Today my subject is reducing the manufacturing cost of cement and increasing the profitability of cement by using the pond ash instead of fly ash. This is a very important topic in the present scenario because in 2017-18, manufacturing cost was 1004 rupees per ton, with the margin of 18.2%. Now manufacturing cost is 1620 rupees tons and margin reduced up to 16.8%. This is the as per source of KRH. My friends, you all know that India's cement industry is internationally recognized as one of the most energy efficient, environmentally friendly industries. We are second largest cement producer in the world next to China. Our installed capacity is approximately 545 million tons. India is a fast growing country, and as per IBEF, Ministry of Commerce, Government of India, that by 2030 our demand may increase up to 800 million tons. It becomes very important that we keep our manufacturing cost at minimum so that we can provide cement at optimum price to our valuable customers. Let's discuss how can we achieve this. As per a recent survey of more than 200 cement plants in India, it was found that average power consumption is 57 units per ton of clinker, but benchmark is 45 units per ton of clinker. Same way, now let's discuss heat consumption. Average consumption is 741 kilocalorie per kg of clinker. It's coming whereas heat consumption in old plants is 820 kilocalorie per kg, and clinker and benchmark is 660 kilocalorie per kg of clinker. You see this graph is a very important leader players cost. So we all know that fuel cost is the maximum of manufacturing cost, and we can reduce it by process optimization, preheaters modification, and cooler replacement. Some plants have recently done this modification and save up to 40 to 50 kilocalorie per ton of clinker. Please see this slide, which clearly shows manufacturing cost of one group is 4479 rupees per ton of cement, and other is 3227 rupees per ton of cement, which is approximately 1250 rupees per ton of less. We can reduce this gap with a small investment, and payback period is very less. I am lucky that I had worked most of the time in group of 3227. Along with this, we can do raw mill optimization, use of AFR, reduction of false air, and optimization of process, etc. With this, we can put a waste heat recovery system which can generate 35 to 50 units per ton of clinker. Like this, we can use roller press, pre-grinder, and existing ball mill. सीताराम जी स्माइल कर रहे हैं क्योंकि many ball mills are independently, so we put roller press. Considering our previous discussion, now let's discuss how we can punish and reduce the manufacturing cost. Only one subject I choose, how to use punish on minimum investment. In this slide, we're showing places in India where big power plants are located and they have millions of tons punish with them. We can use this in our cement making process and reduce the negative impact to earth. As power demand will increase, more power plants will come and more ash generation will be happen. So in this slide, we are showing that in our country we have maximum coal-based thermal power plants. So it's become important to use pond ash, this maximum coal-based plant, the thermal power plant. So it become important to use pond ash to have sustainable solution. As per BIS, 35% of fly ash can be used in PPC cement, but the national average is only 27, and some plants are 20 to 22% in northeast because of high cost. Now let's discuss the cost economics of fly ash and pond ash. This is the waste on one of the cement plant using pond ash. Fly ash landing cost is 1100 to 1200 rupees per ton, and where a pond ash cost is 600 to 700 rupees per ton. Thus, using the pond ash is much better and sustainable option to reduce manufacturing cost of cement and generate the profitability by applying effective pond ash drying combustion chamber. This slide shows the economics of the fly ash. You see 220 rupees per ton of saving. We can install a furnace on the ground floor and connect it with a duct in the inlet of the ball mill and a separator fan inlet. In the furnace, we can use wood piece, coal, AFR, rice husk, etc. And you can get 400 to 600 degree temperature. Why use furnace instead of HAG? The setup of cost of HAG much more than the combustion chamber. HAG cost is about 1 to 1.5 crores and this chamber is hardly 10 to 12 lakhs. Operation cost is also very low due to varieties of fuels and waste materials that can be used easily in the combustion chamber. This shows one combustion chamber connect to 2 ball mills. Recently we commissioned. Now, I think on end note. So, in the product like cement, which is primarily a low value product with a high taxes and duties, so highly thermal power energy, avenue available reduction of the cost are very limited. So, reducing the manufacturing cost by the raw mix optimization, reducing the thermal and electrical energy, grinding technology. We had discussed in details about the use of pond ash with the help of drying combustion chamber and Manekshaw. Thank you for giving me this opportunity. For any further details, you can contact me offline. Let's together we reduce manufacturing cost, negative climate impact with sustainable solution. Thank you very much, sir, and sorry for slightly delay. Thank you.
Thank you, Mr. Manawat. Now, next presentation on enhancement of kiln output by 1,200 TPD through technological upgradation by Lokesh Baheti, Rajesh Srivastava, Dalmia Cement Bharat Limited. Please come on the stage.
Respected Chairman, Co-Chairman, NCCB representative and delegates, good evening everyone. I, Anshul Mishra, along with our other Shri Lokesh Baheti sir and my team members, first of all, thanks to NCCVM for providing this wonderful opportunity to present our paper and share our experiences on the topic enhancement of kiln output by 1200 TPD through technological upgradation. These are the contents of PPT, a brief about the Dalmia cement, the plant at glance, green initiatives taken, the plant journey, introduction of the project, equipment specifications, modification done, and finally the achievements. Let's see, Jayadayal Dalmia ji is our driving force, and it's under the leadership of Sri Punit Dalmia sir, Mahendra Singh sir, we are having the lowest carbon footprint in cement industry globally, and we are committed to be carbon negative by 2040. The plant is located in Rohtas district of Bihar. The nearest attraction points are Bodh Gaya, Varanasi and Patna. This plant is the old retrofit plant of 1939 with drive process in 1992 and finally upgraded in 2020 after its takeover by Dalmia. The current clinker capacity is of 1.1 million ton per annum, cement capacity of 1.7 million ton per annum. These are some green initiatives taken in plant. We are first in India to commission floating solar power plant of capacity 3.79 megawatt. We are having 4 megawatt WHRS. We are also having 25 TPH green fuel co-processing system along with a shredder, which is capable of achieving 25% green fuel TSR with current capacity. These are other initiatives. the journey of the plant starts from 2018 when it took over the Kalyanpur cement, and after that in 2020 the plant was modified. The plant was modified and technology upgraded for 2400 TPD. In 2021, the green fuel pre-processing and co-processing system was installed, and after that in 2022, WHRS and 3.79 megawatt solar was commissioned. As this is the old retrofit plant of 1939 with dry process in 1992, and this plant was of latest technology of that time with offline calciner and single sting preheater of having capacity 1600 TPD and operating at 1445. Dalmia Cement, with a strong vision to revive old sick plants and to be carbon negative, took this plant in 2018. Initially, the PC metal fallout in TAD, lower DOC of bottom stage cyclones, low kill RPM, poor cooler recuperation efficiency, and were the major bottlenecks increasing clinker production. But there was margin in kiln volumetric loading, cooler loading, so our plant team along with the project team under the guidance of Shri Sunil Kumar Gupta sir did a thorough study, and we also took a help of Messrs. KSD for plant technical audit, and finally the plant was upgraded, and the KPIs of the plant drastically improved and has become a benchmark for all retrofit projects in cement industry. These are the equipment specifications before and after. With the same kiln dia and length, we increased clinker production from 1445 to 2740. In this modification, the kiln inlet outlet seal was changed. The top cyclone was changed with a higher efficiency and higher dia. Calciner was changed from offline to inline with a higher residence time of 7 seconds. Cold firing system was changed with a corollis. Cooler grate plates were changed. And preheater fan and baghouse fans were changed with higher volume and higher efficiency. These are the details of modifications done. The calciner was changed from offline to inline with increased resistance of time of 7 seconds. This helped in increasing our bottom stage cyclones DOC, and ultimately our clinker production increased, and higher resistance time in calciner helped us in increasing green fuel TSR to 22%. Top stage twin cyclones were changed with a higher efficiency and higher dia. This helped in achieving saving of SPC 0.5 kg per ton of clinker and SSC 15 kilocalorie. Kiln feed and raw mill feed airlift was replaced with bucket elevator. This helped in saving of 2.5 kWh per ton of clinker. Preheater fan and baghouse fan were replaced with a higher capacity and higher efficiency. Preheater fan helped in saving of 4.5 kWh per ton of clinker. Baghouse fan helped in achieving 1.9 kWh per ton of clinker saving. Kiln RPM was increased from 3.0 to 5.5 operating. This helped in increasing our clinker production by 1200 TPD at the filling rate 12 to 13%. Kiln inlet or outlet seal was changed with a graphite lambda and false reduced from 14 to 8%. This helped in SPC saving of 0.5, SSC saving of 20 kilocalorie. Cooler grate plates were changed with first gate ICANN, second gate and first and second gate were changed with omega plates. This helped in increasing cooler recuperation from 50% to 68% and SSC saving 74 kilocalorie. Cooler fans were changed and DPC was changed with higher capacity. To cater the higher clinker production, raw mill was also upgraded for higher production to 200 TPH. In this, raw mill circuit was upgraded and raw mill fan was changed with higher capacity and efficiency. And VFD also installed. This helped in saving of 11 kWh per ton of clinker. Coal mill was also modified by changing its table and roller and classifier. This helped in saving of 20 kWh per ton of material. These are the process parameter comparatives before and after. We increased clinker production to 2740 with increased kiln volumetric loading 6.7, cooler loading up to 48, and preheater fan volume 380,000. And there was a major change in tertiary and secondary temperature. which increased to 1,050 and 1100 respectively. These are the final outcomes. The kiln output gradually increased from 1445 to 2740. And along with this, greenfield TSR also increased to 22%. Kiln SSC also came down from 871 to 740. Along with SPC came down from 82 kWh per ton of clinker to 46.5 kWh per ton of clinker. Big things does not come by impulse, but by a series of small things brought together. This project is an example of that. Now finally, this is the outcome. We brought down our CO2 emission from 700 kg per ton of cement to 587 kg per ton of cement. And we are further optimizing our solar and WHRS, which has been recently commissioned 2022. And we will bring it down to 545 and further up to 2025 by use of composite cement, 100% composite cement and 40% greenfield TSR. We will bring it down to 400 and further by carbon capturing technology, we will bring it down to carbon neutral by 2040. Thank you.
Thank you. Now, next presentation on plant optimization and modernization, successful case studies by Mr. Vikram and Mr. Prakash Patil from KHD Humboldt Wedge.
Good afternoon, everyone. Myself, K. Vikram, representing KHD Humboldt Wedge. Today, my presentation topic is plant optimizations and modernization. I would like to thank my co-authors, Mr. Sitaram Sharma and Mr. Prakash Patil. First, I would like to briefly touch upon the upgradation solutions of KHD. My teammates in various presentations, they have already explained the salient features of these products, but I'll discuss in one slide. This is regarding the preheater section. In the pyro process system, preheater, we do various types of modifications, whether it is starting from the twin cyclone in the top stage, all the bottom stage cyclones where the involute modifications or cyclone height modifications, increasing the diameter of dip tubes, or the kiln riser modifications depending upon the capacity requirements. These modifications are part of upgradation solutions. Apart from this, the modular solutions of calciner, KHD's tubular calciner is highly recommended for the alternative fuel usage because of the velocities and the pyro top design on top of the calciner. And also the best calciner firing system, I would say, is the pyro box system. These are offered as a part of upgradation solutions. In the clinker cooler section, the static grade pyrostatic to improve the operational efficiency, recuperation efficiency, and also the pocket plates to improve the efficiency of existing grade cooler systems. And I think in one of the presentations in the same session, we heard the improvement of the yellow core. We have supplied the burner in that particular plant. Our burner is highly efficient in terms of the low NOx emissions. Also, the lowest primary air requirement is required for this burner. When it comes to the grinding sections, we have the highly efficient dynamic separator. So productivity enhancement or for power reduction purposes, we have supplied a lot of dynamic separators to improve the operational efficiency of cement grinding circuits. And when roller press is involved, V-separator can be given where V-separator is not installed as a part of upgradation modification solution. So these are some of the solutions that we are offering. There are a lot of other solutions which I cannot bring into a single paper here. Coming to the case studies straight away, in my previous speaker talked about the Dalmia Cement Kalyanpur success story. It is really a big turnaround story, I would say. We have implemented the following modifications in pyro process system. We have suggested to change the kiln feed system to match with the pyro process system capacity. When it comes to the system design, we have replaced the existing top cyclones with highly efficient KHD top cyclones of bigger size. And we have proposed to install a calciner, tubular calciner outside the system because inside the preheater building there was no space, layout constraints were there. So preheater, this calciner, tubular calciner, pyroclone or low NOx installed outside the preheater building with a targeted retention time of 7.5, more than 7.5 seconds. Pyrobox system is installed for the calciner firing application, and custom-made solutions depending upon the layout. We visited, our engineers have done a lot of studies, and then we propose modifications inside the cyclones, whether it is increase of the cyclone height or the increase of the inlet area. A bigger preheater fan is suggested to take care of the increased production of the pyro process system. And also the kiln speed has been increased to 6 RPM by changing the gearbox. And also the kiln critical components like tires, rollers, girth gear, everything has been studied in detail. The stress matrix analysis has been done by Cologne experts. And we suggested that the kiln is suitable for the higher capacity upgradation requirement. And by keeping the skeleton of the existing cooler, that means the casing has been retained and the moving grade section has been replaced with our latest generation PyroStep square cooler plates. And cold dosing system also modified to suit the requirement. These are the modifications we have implemented with the help of the Almia cement. And if you see the results here, we have given a table. You can see that 3 columns are there before modification, what are the figures, and the data given by the, during the contract signing stage. The PG data is given here, and what are the achieved data after the performance test. So I'll focus upon the summary. The production increase of 61% achieved from 1625 to 2617 during the PG test, and heat consumption reduction of more than 100 kilocalorie per kg clinker, and approximately 2.8 kilowatt hour per ton of specific power reduction, and significantly NOx has been reduced. So it is a big turnaround story. The carbon footprint also reduced significantly. You can see the numbers here. Similarly, for the rock grinding system, to match the requirement of the pyro process system, we have modified. Existing roller press has been upgraded. The speed of the RP increased from 1.4 meter per second to 1.6 meter per second. Motors have been replaced with the bigger motor capacity. RP hydraulics, existing hydraulics and roll cock software has been upgraded. We have installed a new V separator for the primary classification purpose, and dynamic separator for the final product classification, integrated with the existing roller press system. And for closed circuit of the circuit, we have suggested to install the bucket elevators to product collection cyclones with the new fan, and also modification in the baghouse fan has been suggested. Here also you can see the figures. I'll straight away go into the summary of the gains. 68% production increase and 1.34 kilowatt hour per ton, specific power consumption reduction on raw mill basis. Coming to the case study 2, we have modified the Birla Corporation NCW Chanderia rock grinding system. Here also it is a very interesting case. We have supplied this original system with 2 roller presses of not equal size. One is smaller RP7 and the other one is RP16. So here the 2 roller presses are integrated with 2 independent V separators and 1 dynamic separator, common dynamic separator is there. Then what we have suggested, the modification includes this mono drive, single roller press having mono drive has been replaced with the twin drive. So the common small dynamic separator is integrated with the smaller roller press with the product collection and the fan system. And the existing roller press, the bigger roller press is connected to the existing dynamic separator and the product collection systems. This has given the flexibility to operate each circuit independently, and the production has been increased. As per the contract guarantee 465, we have achieved 467 TPH. And also at the lower product residue, if we convert it into 2.5, the production will be higher. Specific power consumption saving of 2.5 kilowatt hour per ton achieved in this modification. I'll take only 2 minutes, sir. The case study 3 is again Dalmia Cement Belgaum Pyro Process System modification. A client has given us 2 contracts. One is to modify in phase 1, the other one is phase 2. The proposed modification in phase 1 includes the cooler static grade modification and a partial tertiary taken from the cooler and pyro box installation with modification in the stage 4 meal pipe. These were minor modifications, but all the modifications have been implemented except the bottom stage modification. And in the phase 2 modifications, except the top stage, stage 2 to stage 6, all the cyclones dip tube modifications, cyclone height increase, cyclone inlet area increase, gas riser duct modification, calciner height increase, kiln riser increase, and the calciner bend modifications we have suggested. And we have implemented only the bottom 5 and bottom 6 stage modifications, that is dip tube increase and also the cyclone height increase in involute modifications because of the time constraints in the shutdown period. In phase 1, we have implemented all the modifications. If you see the guarantees, we have given 0.8 kilowatt hour per ton specific power consumption reduction. Against that, we have achieved 1.41. And in heat, we have given 15 kilocal reduction. We have achieved 19. But whereas in phase 2, the implemented modifications, only half of the modification we have implemented. Even though we have implemented half of the modification, we have already achieved the guarantees. Against a 120 millimeter water gauge of pressure drop reduction at the preheater outlet, we have achieved 166 millimeter water gauge. And if we implement all the modifications, the numbers will be much better. What I would like to say here is that we have, in the last 4 years, we have nearly implemented 30 pyro upgradation projects, 25 burner projects. 25 burner means 25 kilns. In 25 kilns, we have replaced the burner. And 10 grinding upgradation projects. These 10 grinding upgradation projects are excluding the roller press installations with the ball mill that generally our CapEx teams looks after. And these case studies and the order intake numbers gives a clear indication that KHD's versatility in designing the plant-specific solutions. And we have also conducted the main the core basic things will come from the plant audits. I would say that the plant audits is very, very important. We have conducted 65 plant audits. When we do these plant audits, we have a specific focus on the debottlenecking areas. And once we identify these debottlenecking areas, the implementation of the solutions will be much easier. I would like to again specify on 2 points. One is the utilization of the existing equipment to the fullest capacity. Through this modification, through this concept, we can achieve the production increase and also the operational efficiency improvement. Second, this concept not only improves the productivity, but there are two advantages. One is the capex of such projects against the greenfield projects will be lower, and also the savings will be realized much faster. So if you have any such requirement, we request you to consult KHD, and in case of any queries, please contact us at booth. Thank you once again, Chair and Co-Chair, for giving me extra 2 minutes. Thank you.
Thank you, Mr. Vikram. Due to time constraint, we cannot take much more questions, but despite that, I requested NCB representative, we can take quickly 2-3 questions. If anybody would like to raise the question, kindly. Quickly, we can take 2-3 questions. Anyone have any question or query? As also, after presentation also, after the session also, you can take up the matter with concern representation. Okay, now I request my co-chairman and my friend, Mr. Sanjeev Srivastava, to kindly summarize the session in short. Mr. Sanjeev.
Thanks to the chairman and coordinator of NCBM, Mr. Anil, for giving me the opportunity to speak on this forum, for giving my views on the productivity enhancement and process optimization session. I will give my views in 2 ways. From yesterday, we are talking about the theme of NCBM is zero net carbon emission as per our target. And a lot of discussion has been taken place, what and who will do what. Some of the data has been already displayed, in which it has been mentioned that 15% carbon reduction, which is equivalent to around 75 to 100, is still possible through the process improvement, productivity enhancement, and technological upgradation. In this session, each and every paper is linked towards that target, how to achieve it. Though some of the old plants with a big investment, like Dalmia Cement, has upgraded their plant for reducing the heat consumption and power consumption, and also some of the plants, Dalmia itself is giving for the focus on FR. That itself shows the commitment of the Indian cement industry that whatever target has been fixed, that will be achieved by the Indian cement industry as for zero net carbon emission. Few papers, though it is not directly related with the carbon net reduction, like quality tools use of commodity tools for the quality improvement, but some way or other way, it is also related with the carbon reduction. If excessive quantity or poor quality, either it suffers this conversion factor or giving the higher heat consumption. So this session is, though it is known as a productivity improvement and process optimization, but I feel that this session is also contributing towards the zero carbon emission session. One paper which is also not related with this, but using the yellow shale for the burnability improvement, some way or other way, it is also related with the reduction in heat consumption and power consumption, better quality improvement, better C3S that will also ultimately convert into the better conversion factor, is also related with the carbon footprint reduction. So thanks to all the presenter and the participants who has listened it, can take something or away, something from this paper to introduce in your plan towards the carbon reduction approach for fulfilling our Indian cement industry commitment as per our target. So thanks to the chairman for your further new addition.
Thank you, Mr. Sanjeev, for very nicely summarize the thing in a very short time, precisely summarize and cover most of the points and make things easy for me. Thank you very much. Our aim is toward moving towards zero carbon emission, which is directly or indirectly related with all these 8 presentations. All are ultimately linked to zero carbon emissions. Gentlemen, as you are aware, due to very huge cutthroat competition across all the industries, including cement industries, it is necessary to reduce the cost, to improve the production, to improve the productivity by means of different things. Then only it is possible to stand in the market. All these 8 presentations are ultimately focused toward upgradation of the plant, plant optimization, quality improvements by using different techniques and tools, use of low-cost material, use of shale and all that, so that we can reduce our cost, improve the productivity, and also make the plant efficient. When we increase the production, it is necessary for us to reduce the heat consumption as well as the power consumption. By upgrading the plants, definitely it will lead to increased productivity, but also the quality and also power and heat consumption, which pay a very high cost. So my congratulations to all the presenter for giving a very good brief information and also presented very nice presentation, which is very informative, innovative, and interesting. Due to time constraint, I cannot elaborate much more. Thanks to Mr. Anil and also to Mr. Sanjeev for giving support and conducting such a nice session. Thank you very much.
Thank you, sir. I would now request Shri Anil Kumar Popri to kindly present mementos to respected chairman and co-chairman as a token of respect. We extend our sincere thanks to Shri Dinesh Ji Randad, Shri Sanjeev Srivastava, and Shri Anil Kumar Popri for their esteemed presence. Ladies and gentlemen, that concludes the session. Let us break for a cup of tea and come back for next session, which is going to be commenced at 4:15 p.m. Thank you all for your kind presence.